Okay, we are all set up and ready to review similar triangles. We start off the unit by proving that triangles are similar. There are three sufficiency conditions for proving similar triangles. The first one is AA similarity, which means if you can prove that two angles in one triangle are equal to two angles in another triangle, then the triangles are similar. The second one is SAS, which means if you can prove that two sides of one triangle are proportional to two sides of another triangle, and the angle in between those two sides are equal in both triangles, then the triangles are similar. The third one is SSS, which means if you can prove that three sides in one triangle are proportional to three sides in the other triangle, then they are similar due to SSS. Now you have to be careful because in order to use SSS, you need to know all three sides in one triangle and all three sides in the other triangle. To use SAS, you need to know two sides in one triangle, two sides in the other triangle, so you need to know four sides in total, and the angle in between them. Before we start, if you could make this correction, just scratch out that X and put a 14 on this side. And then now we are ready to begin. So we have two sides on this triangle and the angle in between. We have two sides in this triangle and the angle in between. So it looks like we're going to be using the SAS, but we have to prove that the sides are proportional. So in the first triangle, side AB goes with side XY. So we start from the 75 and we go to the one of the blank angles here, but it's the shorter side. So that's why that goes with XY. So that is equal to 15 over 10, which is 3 over 2 in those terms. The next side is AC, and it's proportional. Again, you gotta get the letters right. It's going from the 75 to the blank angle, and it's the longer side. That will correspond with XZ. So that is equal to 21 over 14, which is also 3 over 2 in those terms. So we've proven that the two sides are proportional to each other. And now you can say angle A is equal to angle X because they are given. So that means triangle ABC is similar to triangle. Now to get the letters correct, we're going starting at the 75-degree angle, going along the shorter side to the next letter, and then to the third letter. So we're going to start at X, go along the shortest side to Y, and then to Z. You just have to be careful because it's not always in alphabetical order. And the reason is SAS similarity. Question B. We don't have any side lengths, so it's pretty obvious that we have to use the AA sufficiency condition. So we've got some parallel lines, so it looks like we can do some F patterns here. So we can say here angle B is equal to this angle because of the F pattern, but because angle D could be here or here, you have to use the three-letter angle method. So we will say that angle B is equal to angle, instead of saying D, you would say FDE. So that's where the vertex is, right there in the middle. It's basically the same as saying angle B is equal to angle D, and that's because of the F pattern. And we also have this angle here in the left triangle is equal to this angle here in the right triangle because of the F pattern. So because C can be here or here, we have to say angle ACB is equal to angle E because of the F pattern. And therefore, triangle ABC is similar to triangle FDE, and the reason is AA similarity. So that's proving, that's a full proof. So you have to state the information that's equal, how you know, state the similarity statement, and the sufficiency condition. Next is you have to be able to use proportions to determine missing side lengths. To be able to do that, you need to know which side goes with which. So to determine the values of each variable. So side D is in between the 1 and the 2 arches. So that would go with 4.5. Side F is between the 1 and the 3. So that would go with 5.56. That leaves 5.2 to go with 3.9. So that's the full ratio right there. So that's the one you're going to use to cross multiply. So to solve for D, D goes with 4.5. So D over 4.5 will equal, use the ratio that you know both values, 5.2 over 3.9. Cross multiply. So 3.9 times D is equal to 23.4. And when you divide both sides by 3.9, you get 6. So that's solving for D. To solve for F, F goes with 5.56. And that will be equal to 5.2 over 3.9. And when you cross multiply, you get 3.9F equals 28.912. Then dividing both sides by 3.9, F is equal to 7.4. Alright, moving on to question 3. With these triangles, what you want to remember is that they're almost kind of twisted. So, X will go with the 6, not the 5. So it's like the opposite here because of Z patterns both ways. The 8 goes with the 5, and the 12.8 goes with the 8. So we just have to solve for X in this question. So we have X over 6 equals 8 over 5. Cross multiply. 5x equals 48. And dividing both sides by 5, you get 9.6. And that's it for that question. Lastly, these are the trickiest ones when you've got one triangle inside of another triangle. So what I always suggest doing is separating the two triangles. So you've got the small one here. So this is X, this is 3, and you've got the big triangle. This is 6. This here, it's this entire length here, which means it is X plus 4. So the X will go with the X plus 4. The 3 will go with the 6. x over x plus 4 equals 3 over 6. When you cross multiply, this way you get 6 times x. This way you get 3 times x plus 4. So you're going to have to use distributive law. 6x equals 3x plus 12. Subtract 3x from both sides. And divide both sides by 3. So that gives you x is equal to 4. So that's what you need to know about similar triangles, both proving that triangles are similar and solving for missing side lengths. So if there's anything you didn't understand, please make note of it and ask your teacher during the next day. Hope you enjoyed similar triangles. Thanks and bye-bye.